Right, so for a limit to exist, the limit of a function as x approaches from the right has to equal the limit of a function as x approaches from the left. Right, so our right-hand limit has to equal the left-hand limit. In other words, we just have to approach the same value coming from the left-hand side and the right-hand side. So notice that f of c doesn't have to exist, just that coming from the right and coming from the left, the function needs to be going to the same value. We don't care what happens at c, we care about what happens as we get closer and closer to c. Right? In this podcast, we're going to be looking at piecewise functions. So if the function is piecewise defined, you must perform the substitution from both sides of x. Right? You'll have one equation for the right and one equation for the left. The limit exists if the sides yield the same value. If different values are produced, we say the limit does not exist. So here, all we need to do is check on both sides. We have to use both parts of our function, right? Both pieces, right? And see, do we approach the same value from the left and the right-hand sides? Do the two sides meet? Right? So here we want to find the limit of f of x as x is supposed to be an arrow, but x approaches 0. Right? So right here, we've got, if we want to find the limit of f of x here, we have to check and make sure that we approach the same thing from the right-hand side and the left-hand side. All right, so here from our left-hand limit, just a reminder, that negative on the after the 0 means left. From the left-hand limit, right, we'd plug into this one. Right, so this would tell us the limit of our function as x approaches 0 from the left. Right? And if we plug in 0, we get 1. Right? And so the x greater than 0, that will give us the limit of our function as we approach 0 from the right. And if we plug in 0, right, we get, well, 0 squared is 0, so we get 1. So notice that the left-hand limit equals the right-hand limit. Right, so here, in this case, the limit as x approaches 0 is equal to 1, right? Because both of our one-sided limits, the right-hand side and the left-hand limits, both of those were 1 as well. Right, so the limit as x approaches 0 is equal to 1 because we have the same value from the left as we do from the right. We're approaching the exact same value. So here, all you have to do is substitute, right? And you get the same things coming from the left and the right. All there is to it. Right? And here we have a graph of our function, and you can see, any day now. There you can see it. So 0 and x squared plus 1 when x is greater than 0. And you can see that as x approaches 0 from the left-hand side and the right-hand side, we're approaching the same value 1. Right? So we approach the exact same thing. All right, so we're going to here, again, we'll find the indicated limit. All right, so we're finding the limit as x approaches 2. All right, so our left-hand limit, if we plug in 2, we have 2 squared. It's 4 plus 1, it's 5, right? So the limit of f of x as x approaches 2 from the left, that's 5. If we plug in 2 to the other piece, we'd have 5 times 2 minus 3, that's 7. So the limit of f of x as x approaches 2 from the right is 7. So notice they're not equal to one another, right? So the limit of our function as x approaches 2 does not exist. And that's because the limit of f of x as x approaches from the left does not equal the limit of f of x as x approaches from the right. We're getting two different values. So the limit does not exist. So since the one-sided limits are not equal, we say the limit does not exist. There's going to be a jump in this graph at x equals 2 as we go from one piece to the next. All right, so here we're going to find some more limits. Nobody says we have to find them always just at the endpoints. We could find them someplace else. A couple of these has it someplace else. So consider the following piecewise defined function. 1 minus 3x plus 2x squared, if x is less than negative 2, and 25 plus 3x minus x squared if x is greater than negative 2. And you know, I think I'm going to probably need a little bit more space. So what I'm going to do is I am going to, oops, come on. Nope, not what I wanted to do. Inserting, I don't want to end the podcast. Come on. All I really wanted to do was clone my page. I'll try one more time. It seems I won't. It never likes to do things if I say, while I'm recording, I say, oops, I would like 2 of these pages. It says, nope, you can't have them. Aha! Aha, I tricked it. Yay! I think it cloned it anyway. All right, well, that's good. Now I think I got 3 of them. All right, so now I'm going to cover up so we have some space. I don't know why I didn't think of this earlier. It's going to get crowded over here. So I will just turn this, cut that out. How long will it take me? Undo that. All right. All I want to do is properties. Yay! Turn this into a big white box. There! Actually, now I should have cloned it because then I could just push the box up. But all right, so we're going to find the following limits now that we have some space. All right, so we're going to find the limit as x approaches negative 2 from the left. So that means I need to plug into the less than negative 2. All right, so my limit is going to be equal to, and so I'm just going to work my way down. So A, the limit as x approaches negative 2 from the left, and I'm not writing that, we're just writing f of x because it's defined to be f of x, is going to be equal to, so we'll plug into into the x less than negative 2, that's the left. So that would be 1 minus 3 times negative 2 plus 2 times negative 2 squared. So that's going to be 1 plus 6, and that's going to be 4 times 2, that's going to be plus 8, so that's going to be 15. All right, so that's our left-hand limit. How about, I think our right-hand limit is coming up. All right, so our limit of our function as x approaches negative 2 from the right, so now I need to use the for greater than negative 2. We're going to have 25 plus 3 times negative 2 minus negative 2 squared. So that's going to be 25 plus 6, and that's going to be minus 4. So that would be, right? Yes. Yes, because that would be negative 2 squared is 4. All right, so that's going to give us 31 minus 4. That's 27. All right, so now we want to find the limit of our function as x approaches negative 2. Well, that's going to be does not exist, right? Because the limit as x approaches negative 2 from the left does not equal the limit as x approaches negative 2 from the right. And our suggestion, get into the habit on the does not exist of, at least for some things, putting y, like this one, right? So not maybe for everyone, but for an obvious one like a piecewise, where the left and right hand aren't matching, right? It's a good idea to write y, because on the AP test, right? That might help you, right? By explaining why it doesn't exist, right? We don't have the same limit. Let's continue on. Let's do -3. Now, -3, not going to be a problem, right? It's not at a breaking point. So it's just, we're just plugging into a polynomial function. So the limit as x approaches -3 of f of x, that's just going to be, so we need the greater than side, that's just going to be 25 plus 3 times -3 minus a -3 squared. I gotta make sure I keep plugging in the right value. All right, so that's just going to be 25 plus 9, and that's going to be minus 9, right? So equals 25. And that's all there is to that one. We don't need to worry about a left and a right hand limit because it's a polynomial function, right? It's going to be coming from the same side from the left and to the right. So now we have the last one, which is -1. The limit as x approaches -1 of f of x. All right, so we just plug in now to the less than. 1 minus 3 times -1 plus 2 times -1 squared. That's going to be 1 plus 3 plus 2, so that's going to be 6. So now we don't have to worry if we're not at the breaking point where we switch functions. We only have to worry if we're finding the limit right at the breaking point. So there is A, B, C, D, and E. All right, so now let's do those other problems on the page. Aren't you glad I gave myself more space? All right, so now we're going to have to cover up the other problems. So I wonder if it'll just let me do this. Push them out of the way. There we go. I don't think I can do that always, but I'll deal with it later. There we go. We just push it away. All right, so we want to find, first of all, the limit of f of x as x approaches 2 from the negative side. So the left-hand limit, we need to plug into the less than 2. All right, so that would be 3 plus 2 times 2 plus 2 squared, which would be 3 plus 4 plus 4, which is 11. Now we want the right-hand limit. So the limit of f of x as x approaches 2 from the right, that's going to be 3 plus 4 times, wait, da-da-da-da-da. So it really helps choose the limit on the right-hand side first. 6 plus 2 times 2 plus 2 squared. Right, so I keep having to look up and stuff, so sometimes I'm writing the wrong numbers down. 6 plus 4 is 14. So now the limit as x approaches 2 of, oops, why did I put the 2 up there? Don't really have an answer for that. F of x does not exist, and that's because the limit as x approaches 2 from the left does not equal the limit as x approaches 2 from the right. Right? Not approaching the same value. Let's find D, the limit of f of x as x approaches 1. No problem, right? Because we just need to plug into the less than 2. 3, and it's polynomial, so it's going to be approaching the same value from the right and the left-hand side because we're not at the breaking point. 3 plus 2 times, we're approaching 1, right? 1 plus 1 squared is going to be 3 plus 2 plus 1 is 6. And then finally, last but not least, E, the limit as x approaches 3 of f of x. we'll just plug into the greater than. So 6 plus 2 times 3 plus 3 squared is 6 plus 6 plus 9, which is going to give us 21. And that's it. All right, so on piecewise defined limits, if you're not at the breaking point, well, you just use substitution, not worry about it. If you're at the breaking point, you got to plug into both the left and the right hand sides, right, to see, are you approaching the same thing, or does it jump when you go from one function to the other? Thanks for watching. Bye for now. Oh, let me just double check. I believe this is the last slide, not including this one that accidentally doubled, and this page they accidentally put in a blank one for, and oh, we have a 30 and a 4. Oh, it's a good thing I didn't end. Never mind. Welcome back. Let's keep going. It would have just been a part 2. All right, so again, actually I will try desperately to clone the page, not put in another blank page. Where the heck, there it is. Okay, so yeah, now we have clone page. I'll cover this up. Let's do these last ones. Maybe we'll have a surprise, I don't know. Regardless, I want to do a few more problems since I have them here for you. And I may say something really important, like, ooh, there we go, as I'm going through these. So change that. I can't get rid of the box. I want to get rid of the lines too. Well, we might be stuck with the line, the big box there. Yep, we're stuck with those lines. All right, we'll just work around it. No big deal. All right, so A. So the reason I want to go over this one, look at this one. This one's got 3 parts. So I told you there might be a little surprise. All right, I almost forgot the one with 3 parts. All right, so now we've got more places for left and right, don't we? All right, so we have the limit of f of x as x approaches 1 from the left. That's still going to be the less than 1. All right, so that's going to be negative 1 plus 2 times negative 1 plus 2 times, positive 1. 2 times 1 plus 2 times 1 squared, which would give us negative 1 plus 2 plus 2, which is 5. How about the limit of our function as x approaches 1 from the positive side? All right, so that's going to be, now we're going to use the greater than. You're going to ignore the equals, use the greater than, right? Because we're coming from the left and the right hand side. We don't care what it equals. So if you told me the limit is 2, well, you're wrong, right? It's not what the value of the function, it's what's approaching from the left and the right hand sides. All right, so now let's find, we're going to plug into the greater than side, right? Well, that's going to be 6, right? Because it's going to be 6 if x is greater than 1. So here for question C, the limit of f of x as x approaches 1 does not exist because the limit as x approaches 1 from the negative side does not equal the limit as x approaches 1 from the positive side. Another question I could ask, but it's not up here. Let's just call that f, and I'll put it right here. My f is going to be, what is f of 1? Well, f of 1 is 2. Now we'd use that value. So if we want to know the value of the function when x is 1, that's 2. If we want to know the limit as x approaches 1, we have to look at what it's approaching from the left and right hand sides and ignore what it equals. And you can see it's not approaching the same thing. All right, so let's take a look at D. The limit of f of x as x approaches 0. Now we just use a less than 1. So that's going to be negative 1 plus 2 times 0 plus 2 times 0 squared. So, well, that's just going to be negative 1. And then finally, on this page, I'm going to do one more set. The limit of f of x as x approaches 2. Now we got to use the greater than side. Well, that's 6. So anything greater than 1 is 6. And we're done with this one. Let's look at the last one, which is the same page, but we're going to do the bottom set. There we go. All right, so we can use that particular one right there. It's not the same. Doesn't that look like really, really similar to one we just did back here? I just want to make sure I'm not losing my mind with all these blank pages. No, it's different there, different there. Okay, just to see all those 3s again. And I'm like, that's the same one, is it? No. Just a little similar. Let's find out what happens here. All right, so we're going to do these 5. The limit. But that last one was kind of interesting, right? Because we had 3 pieces, right? As x approaches negative 1 from the negative side. And so actually, if we had another piece here, then we would have another. Actually, let's write another piece in. So now this is going to be, I'm going to change this. Let's just change this one because this is a little bit like the last one. And I'm going to make that when x is greater than or equal, or excuse me, less than or equal to. So let's see. That'll be less than or equal. Oh, sorry. We already had the less than or equal to. Oh. Third try will be a charm, I promise. So if x is greater than negative 1, but less than 0. All right, and then so for 0, let's just make it 5. Let's make it 4x. 4x if x is greater than or equal to 0. Let's give ourselves 3 pieces here, just to make it interesting. All right, so we have the limit as x approaches negative 1 from the negative side, f of x. All right, so we're going to plug into the less than. We'll have negative 3 plus 2 times negative 1 minus negative 1 squared. And negative 1 kind of. So this would be negative 3. Still in the wrong spot. That's all right. You know it's a negative 1. Negative 3 minus 2. That's going to be minus 1. So that's going to be 0. Let's find the limit. As x approaches negative 1 from the positive side. So now I'm going to plug into the as greater than. All right, so that's going to be negative 3 plus 2 times negative 1. And that is, we have the same function for both. I don't know why I just noticed that right now. But how boring. How boring. Let's help this one out a little bit. And make it a plus. I'm going to just rewrite this. By the way, I did not write these questions. I saw them. I liked them. Didn't notice that one of them was exactly the same. It's not really a piecewise function. Just do the same thing. All right, so negative 3 plus 2 times negative 1. Now it's plus negative 1 squared. All right, so that's going to give us negative 3. I guess if I've written it correctly, we should have had one that it was equal. So we could say, hey, this is the limit. There's a whole lot that does not exist, doesn't it? But that's OK. Negative 3 minus 2, and then plus 1. So now it won't be 0, because now it's going to be negative 4. All right, yes. Oh, but why did I say, well, all right. 3 minus 2 is minus 1 is 0. Negative 3 minus 2 minus 1 is a negative 6. But either way, on C, the limit of f of x as x approaches negative 1 does not exist because the limit as x approaches negative 1 from the left does not match the limit as x approaches negative 1 from the right. I would have liked it. I should have rewritten this before I made the tape. I should have rewritten it so it would be the same, but not the same function. Let's see how wise. I may change that, the 0, 1 there. All right, so D, the limit as x approaches negative 2 f of x, you just plug into the less than 1. So this would be negative 3 plus 2 times, and we were doing negative 2, my shadow was blocking, minus negative 2 squared is negative 3 plus minus 4, and then minus 4, right, because that would be plus 4, so now it's minus 4. So negative 11. I will not forget that 3 is negative. Maybe if we just made the 3 positive. Be more interesting. All right, so E, and then on E, we're going to take a look from the right and the left-hand sides. So, because now I made it more complicated. So the limit as x approaches, so if I want to know the limit as x approaches 0, I have to find it from the left-hand side. All right, so from the left-hand side, I'm going to make one little change. I can do that because I made up the function. I'm going to call it, no, yes, actually, we'll keep it the 4x. We're going to make it 4x minus 3. All right, so that's going to be that if x is greater than or equal to 0. All right, so from the left-hand side, we plug into the left-hand function. So that would be negative 3 plus 2 times 0, and then plus 0 squared. So that's just going to be negative 3. And we plug into the right-hand side. X approaches 0 from the right, and we get 4 times 0 minus 3. Look at that! It's negative 3. So in this case, our limit exists because I was tired of seeing does not exist. So the limit as x approaches 0, and our new function, f of x, is negative 3. Yay! And that's the end of this podcast. It's a little longer than I had planned. But you got lots of practice with Piecewise. And so no matter how many pieces you have, it doesn't matter. You just look for the ones that are from the left and the right of your piece. Or if you're not at a breaking point, you just plug it into whatever piece it's supposed to go. Bye for now. Thanks for watching.